In this section, we're going to graph equations by plotting points. This is one of the easiest ways to graph an equation because all you have to do is just basically substitute values into an equation until you get the picture you want. So, one of the things we're going to do is look at this first example. You're given x plus 5y is equal to 18. If we let x equal to 3, we can figure out what y is equal to by just substituting 3 wherever we see an x. So we got 3 plus 5y is equal to 18. Now, by just solving for y, we're going to subtract 3 to the other side. We'll get 5y is equal to 15. And divide both sides by 5, we'll get y is equal to 3. So what that says is that when we have a point such that x is equal to 3, that tells us the y value then has to be 3. We can also check the result that we were just given by, now that we know the point, substitute the point coordinates into the equation. So again, let's start by writing the equation x plus 5y is equal to 18. Then we said that the x coordinate was 3 plus 5 times the y coordinate was also 3. And what we want to know is, does this equal 18? So in solving the left-hand side of the equation here, we have 3 plus 15 should equal 18, and 18 is equal to 18. When this is the case, and both sides are equal to one another, then the point represents a solution to the given equation. Okay, now let's look at how we would graph an equation using this plotting points method. So what we're going to do is create a table, and our table will have x values. Now I'm just going to pick some random x values. So we're going to say, let's say the number 1, the number 2, and we'll pick -1. So these are x coordinate points that we're going to choose. Now we're going to substitute these x's into the equation to figure out what our y value is going to be. So to figure out what y is going to be, we're going to substitute 1 into the equation. So -1 plus 3. I know that -1 plus 3 is equal to 2. Trying the next one. Here we have -2 plus 3. And then -2 plus 3 is going to give us 1. The last one, let's substitute -1 in. So -1 plus 3. I know that a negative and a negative is a positive. So that's +1 plus 3 is equal to 4. Now we're going to take the time to plot each one of the points that we just found. So we're going to go, let's pick a different color here. We're going to go 1 unit to the right, 2 units up. So our first point is located at 1, 2. Our next point was located at 2, 1. So we're going to 2 units to the right, 1 unit up. The last point we showed here, is located at -1, positive 4. So -1, positive 4 gives me a point here. Now, if I had a straight edge, I'd take and draw a line that goes through all 3 points. So something like this. Of course, I don't have a straight edge, and my graph isn't exactly right, so you get the idea, hopefully. So the points, I can draw the points a little better. So that each one of the points passes through the line of the graph that we have here. So we've just created our first, graphed our first equation by using points. Okay, here's another one. In this case, we've gotten a little bit more complicated of an equation. We got y is equal to x squared plus 3, which we know to be quadratic. And what we're going to do is, again, create the graph of this equation by plotting. So, what we're going to do is create a table. This time I'll pick more points. Let's pick -2, -1, 0, +1, +2. Now we're going to substitute each one of these values into my equation to figure out what y is. So the first one, I'm going to substitute -2 in for x, square it, and then add 3. In this case, -2 squared is 4, plus 3 gives me 7. The next one, -1 squared plus 3, so -1 squared is a +1, so 1 plus 3 equals 4. 0 squared plus 3, 0 plus 3 is 3. Here, 1 squared plus 3, +1 squared is 1, and 1 plus 3 is 4 again. And the last one, 2 squared plus 3 will give us 7 again. Now let's graph the points on the graph. So the first point we were given was -2, 7. So we're going to go -2 to the left and 1, 2, 3, 4, 5, 6, 7 up. So here's our first point. The next one, we're going to go -1 to the left, 4 up. So -1, 1, 2, 3, 4. We get a point roughly right here. The next one, 0, 3. So 0 at the origin, then 3 up, 1, 2, 3. The next one, 1 to the right this time, and 4 up. So 1 to the right, 1, 2, 3, 4 up. And the next one is 2 to the right, 7 up. So I got a graph that looks somewhere right here. Now, see if I can do a better job of going through all the points. So we've got a graph that looks like this. Alright. So here's our curve that we were able to draw using our point plotting method. The last thing we're going to discuss today are the x and the y intercepts. The x-intercept just simply means where are all the places that the graph touches the x-axis. So we know that the x-axis represents this horizontal line here, and the y-axis represents this axis. So we're going to draw we used a blue circle to represent all the x-intercepts. So here, we have an x-intercept located here, 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 and here. So these are all the places we have an x-intercept. And in green, we're going to label all the y-intercepts. In this case, the graph only touched the y-axis one time. So we're going to say that this is our only y-intercept. So writing that down, we're saying that the x-intercepts are -5, sorry about that, -2, +2, and +4. So these are all of my x-intercepts. So we're going to put x is equal to each one of these values. The y-intercept, put on this side here. Let's do it in green. So the y-intercept is, or is in this case, y is equal to +4. Okay. So the x-intercepts just simply mean where did the graph cross the x-axis or the horizontal line, and the y-intercept is where does the graph cross the y-axis or the vertical line. Okay. All right. Thank you very much.